Today we're taking a look at some sample problems from section 7-3, and those problems begin on page 356 in your textbook. We'll begin with exercise number 2. It says degrees of freedom. For the accompanying screen display, a simple random sample of size n equal to 40 was obtained from the population of duration times in seconds of eruptions of the Old Faithful geyser. What is the number of degrees of freedom that should be used for finding the critical value for T sub alpha over 2? Okay, the screen display is actually on the previous page, and it says n is 40 as well as the problem tells us n is 40. So in part A, that means our degrees of freedom would be 40 minus 1, which is 39. Degrees of freedom will be 1 less than the n. B, find the critical T sub alpha over 2 corresponding to n equal to 40 and a 95% confidence level. So degrees of freedom is 39. Alpha is going to be 1.00 minus 0.95. Since our confidence level is 95%. So those are the two that we need for our table. And I think I've got my table here. I have to adjust my window. Oops, had it and lost it. All right. Alright, so degrees of freedom is 39, so I need to scroll down, and I want alpha to be 0.05 and 2 tails, so that's the middle column. So 2.023. Okay, give a brief description of the number of degrees of freedom. In general, the way we find the number of degrees of freedom is to take our n and decrease it by 1. Because when we're looking at any number above 1, we have at least 2 choices. Once we get down to simply 1, we're restricted to selecting that 1. So degrees of freedom is 1 less than the number in the number of trials or number in the sample. Okay, let's go down to number 5. The confidence level is 95%. Sigma is known to be 4,385,000. We have a dot plot of the sample of Red Sox baseball players' salaries, and we're asked, it says use the correct distribution. Assume that we want to construct a confidence interval. Do one of the following as appropriate. A, find the critical value T sub alpha over 2. Find the critical value Z sub alpha over 2. Or C, state that neither the normal distribution nor the T distribution applies. Okay, so if we count the dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we have 12 dots. So n is 12. That means we need the original distribution to be normal. And we're not given any information to that effect, so because the sample is so small, neither applies. Okay, let's look at number 6. Confidence interval, confidence level is 90%. Sigma is not known. The dot plot of IQ scores of 20 randomly selected statistics instructors is as shown below. Alright, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19. We have 20. We know IQ scores are normal. So because of that and the fact that sigma is not known, we would have to use a t sub alpha over 2. And our degrees of freedom, we've got 20 would be 19. Okay, and alpha is 10 because we're told a 90% confidence level. So we need to go to our table again. Alright, so I need to scroll up to see which column. I want 10% in the two tails, and for some reason it keeps bouncing back down. Okay, 10% is the next to the last column, and we want 19. Okay, and it's still giving me fits. It's like the pen is controlling it. Okay, so I'm looking at 19 in the next to last column, 1.729. 1.729. Okay, and again, the reason we use that is sigma is not known. Alpha is 10% or 0.10 in two tails. Degrees of freedom would be 19. We know that IQ scores are normally distributed. Okay. Number 10. Listed below are the amounts of mercury in parts per million, or ppm, found in tuna sushi sampled at different stores in New York City. The study was sponsored by the New York Times, and the stores in order, and they list the stores. The sample mean is 0.719 ppm. So X bar 0.719 ppm. And the standard deviation is 0.366. Okay. Construct a 90% confidence interval estimate of the mean amount of mercury in the population. Okay, so we're given some information here. We want to calculate our value for E. So we can construct our confidence interval, and our N is 1, 2, 3, 4, 5, 6, 7. So degrees of freedom would be 6. Confidence level I want is 90%, so alpha is 10%, 0.10. So our T sub alpha over 2, we've got to go to our table. We want to use degrees of freedom, 6, and alpha equal to 10, 0.10 I should say. Alright, we're in the next to the last column, and degrees of freedom is 6. So we want to go across, so it's going to be 1.943. 1.943. So E will be 1.943 times 0.366 divided by the square root of 7. Okay, so using my calculator, 943 times 0.366 equals divided by the square root of 7. So I'm getting 0.1978. So now we need to take our 0.719 minus 0.1978 and our 0.719 plus 0.1978 minus 0.1978, 0.521 and 0.719 plus 0.1978, and that's 0.917, assuming I didn't make any mistakes here. Okay, evidently I have an error. Let's see. .91719. I'm just checking my figures. 0.366. Okay, and we had degrees of freedom is 6. Alpha was 0.10. Let me double check the table value. Table value. All right. 6, 1.943. Area and 2 tells, that's right. Alright, maybe it's what I entered in the calculator. 1.943 times 0.366 divided by the square root of 7. Oh, I get a very different answer, so I must have hit a wrong key somewhere. Okay, I'm getting 0.2688. So let's correct that. 2688, 2688. Alright, so 0.719 minus 0.2688. I get, that sounds better. 0.450 and 0.719 plus 0.2688 is 0.988. Okay, and those would be ppms. Don't quite have enough room here to put it on the same line, so I'll write it underneath. Okay, let's move on to number 16. This is an insomnia treatment. A clinical trial was conducted to test the effectiveness of the drug